In Module 2, we learned how to create a table of numbers that moved a simulation of a speaker up and down on the screen. And we learned how the same table of numbers could be used to plot the graph of a sine function. In this module, we learned how to create that same table of numbers and send it to an actual computer speaker to create a real tone. So this module is basically about computer-generated sound, how a computer artificially generates sound, like a pure tone or even noise. In this extension of Module 3, we're going to take a look at how these tools could be used and applied. In this video, a bass guitar string is moving back and forth at 40 times a second. The movement of the guitar string is captured by the computer, turned into numbers, and then sent to the speaker. The key thing to note is that each time the guitar string moves forward, so does the speaker, and as it moves backwards, the speaker does as well. Essentially, what is happening is the back and forth movement of the guitar string is digitized by the computer and then sent back out to the speaker. Sampled sound starts with a digitized natural sound. Synthesized sound begins with a table of numbers created inside the computer. So previously, we learned how we could generate a sine table. And in this case, I've taken this procedure, which is essentially what you saw in the previous video, and created a procedure called create a tone. When I create a tone, it generates this table of sine numbers that we've seen in previous modules. And then if I draw a graph of that, I get something like this. If I send that table of numbers to the computer speaker, I hear something like this. Now, I can also generate random noise. So in this second procedure, when I look inside, it says just create a whole series of random numbers, create a table of random numbers. And if I do that, click create a noise, and I look at this, what's inside, well, I do have 0.6, 0.9, 0.5. However, if I create another table of random numbers, the numbers are going to be completely different. Now it's 0.6, 0.7, 0.9, and so on. I'll do it a third time. Create a series of numbers, and each time, now it's minus 0.5. Each time the numbers in the table are different. And if I plot those, we see that there's no discernible pattern. It's just random numbers. And if I play it, it sounds like, well, it sounds like noise. So the difference is that the sine table is a regular periodic sound that repeats. If I draw that, it's the same pattern over and over again. And the height of the pattern, the height of the graph, determines how far the speaker moves forward at the top and how far it moves backwards at the bottom. And it does that over and over, moving the speaker back and forth. The noise also moves the speaker back and forth, but because there is no pattern, we perceive it as noise, meaning something random. And that is how sounds get artificially generated through a table of numbers, and how we can use them to create music and speech synthesis.